So over the last few sections, we have learned all about common JavaScript data structures and also strings. But now it's time to turn our attention onto two additional ways of representing data: numbers and dates. Now, these might be a bit less important than things like strings and arrays, but you should still know how to use them. And so in this section, we will continue working on the Bankist app, but now we will incorporate numbers and dates and also internationalization and timers, which are another two very important aspects that you should actually know about. Let's start this section by learning how numbers work in JavaScript, how to convert values to numbers, and also how to check if certain values are numbers or not. And before starting this section, go ahead and open up your starter files for this section so that we can take a look here at the script.js. So as I said in the last section, in this one we will continue working on our Bankist application. Okay. Now, what's different here is that now we have actually different data. So we have only two accounts now here, and each account now has a new array which contains the dates of the movements. We also have the currency property and a locale property. All right. And so we will use this data in later lectures of this section. Okay. Then down here we have the complete application that we built in the last section. And if you want, you can go ahead and replace this entire code that I have here with your own code from the last section. Okay. What matters here is that we make the application work just as it was working by the end of the last section. All right. So again, we have the same application, only the starter data is a little bit different, but everything else is the same. And so now let's start learning a little bit about numbers. And the first thing that you should know about numbers is that in JavaScript, all numbers are represented internally as floating point numbers. So basically always as decimals, no matter if we actually write them as integers or as decimals. So we can show that by doing this. So we need a new terminal here. And so here is our application back again. Let's close this and open up the console. Give it some more space. And so you see that 23 is in fact the same as 23.0. Okay? And that's the reason why we only have one data type for all numbers. Also, numbers are represented internally in a 64 base 2 format. So that means that numbers are always stored in a binary format. So basically, they are only composed of zeros and ones. Now, in this binary form, it is very hard to represent some fractions that are very easy to represent in the base 10 system that we are used to. So base 10 is basically the numbers from 0 to 9, while binary is base 2, and so that's the numbers 0 and 1. Okay? So as I was saying, there are certain numbers that are very difficult to represent in base 2. And one example of that is the fraction 0.1. And that then results in very weird results like this. And this is kind of a classic or a running joke in JavaScript because this result should of course be 0.3 and not with all of these zeros here. But JavaScript simply has no better way of representing this number. So in base 10, 1 divided by 10 is simply 0.1. And so that's very easy to represent. But for example, if we were trying to do 3 divided by 10, then that is also impossible to represent for us, right? It would be this number here and 3 until infinity. Okay? And so in binary, the same thing happens with 0.1. So we get basically an infinite fraction, and that then results in a weird result like this one. Now, in some cases, JavaScript does some rounding behind the scenes to try its best to hide these problems, but some operations, such as this one, simply cannot mask the fact that behind the scenes they cannot represent certain fractions. And by the way, many other languages use the same system, for example PHP or Ruby, and so don't let anyone make fun of JavaScript because of this. Okay? So we just have to accept that it works this way because we really cannot do anything against this. So just be aware that you cannot do like really precise scientific or financial calculations in JavaScript, because eventually you will run into a problem like this. So point 2, which will result in false, which of course is incorrect, as we know. This should be true, but, well, this is simply an error in JavaScript that we have to accept. Okay? All right. Now that we know how JavaScript represents numbers, let's go back to actually working with them. So we know how to convert a string to a number, right? So that's like this. But there's also an easier way, so kind of a trick that we can use, which is to, or actually this should be a string, otherwise that doesn't make much sense. But as I was saying, there is an easier way, which is simply plus 23 the string. And this works because when JavaScript sees the plus operator, it will do type conversion. So it will automatically convert all the operands to numbers. And so therefore we see 23 here in both these cases. So in this purple color, which are numbers. So this here makes our code look a lot cleaner in my opinion. And so let's now actually go to our project and replace all the occurrences of number simply with the plus sign. So here, if I save it now, the prettier extension should get rid of the parentheses here, and it does. So here and here and here as well. And that should be it. Yeah, that's it. Great. And so our project will work the same, but the code is a little bit cleaner now. Okay, so here we converted strings to numbers, but we can also do something called parsing. So we can parse a number from a string. So on the number object, which is kind of this function here, but it's also an object in the end, remember, because every function is also an object. And this number object here has some methods to do parsing. So let's use parse int. And so here we can now specify a string, and that string can even include some symbols. And JavaScript will then automatically try to figure out the number that is in this string. All right. And so here we get 30. And this is actually a number. It's not a string. All right. Now, in order to make this work, the string needs to start with a number. So if we have something like this, then it's not going to work and we get not a number. Okay. So this is a little bit like type coercion, but even more advanced, because as we just saw, it tries to get rid of unnecessary symbols that are not numbers. And this can be very useful, for example, in this situation, where we get some kind of unit from CSS and then need to get rid of that unit. Now, the parseInt function actually accepts a second argument, which is the so-called radix. And the radix is the base of the numeral system that we are using. So here we are simply using base 10 numbers, so numbers from 0 to 9. And most of the time we are doing that, and so we should always pass in the number 10 here. Okay, so that can avoid some bugs in some situations, and you see the result here is the same. But if we were working, for example, with binary, then we would write 2, and then the result would be completely different. In this case, we cannot even see it, but let's just keep using 10 here. So this is with integers. So that's what the int here stands for. So parse integers, but there's also parse float. So number dot parse float. And let's now try 2.5 rem. And so now it reads the decimal number here from our string. So a floating point number. Let's see what happens if we used int. And then we only get the integer part, right? So it will then stop here at this decimal point. But that's of course not what we want. And by the way, we could even have like some white space down here that would not affect anything at all. All right. Now, by the way, these two functions here are actually also so-called global functions. So we would not have to call them on number. So this here also works. Okay, but this is the more traditional and old school way of doing it. Now in modern JavaScript, it is more encouraged to call these functions actually on the number object. Okay, so we say that a number here provides something called a namespace. All right, so a namespace for all these different functions like parse float and parse int. But anyway, let's now explore another function of the number namespace, and that is the isNan. So is not a number. So number.is not a number. And we can use this one to basically check if any value is a number. Well, not any value, but more about that later. So for example, if we pass 20, then here we get false. And so is it not a number? False, right? So let's try the same with the string 20. And so here we also get false, all right? Because this also isn't not a number. It's just a regular value, right? But now let's try it by converting something. So for example, this string, if we try to convert it to a number, then this will be not a number, right? And so therefore it is true. So let's just do that here. So yeah, this works as well. And so you see, this is of course not a number. All right. But let's try something else. Let's, for example, divide 23 by 0. And maybe you know that dividing by 0 gives us infinite. Okay, so dividing by 0 is something that's not allowed in mathematics. And so it will give us infinity. So infinity is also not a nan. And so therefore we get false here as well. So let me just demonstrate that here. So indeed, this gives us this special value of infinity that also exists in JavaScript. And so this is not a number is actually not a perfect way for checking if a value is a number, because it doesn't consider this use case. And sometimes this might very well happen. And therefore, there is a better method called isFinite. So number is finite. And let's try it with the same numbers. So here we get true. Okay. So basically, this should be the opposite now of this one, because this is not a number, but it is finite. Okay. Now, if we try it with 20, the string, then here we get false, because it's not a number. And so this is actually better to check if something is a number or not. And I know this sounds a bit confusing, and the confusion comes from the fact that we have this weird thing here that is also called not a number. All right. And therefore, I'm just telling you that the isFinite method is indeed the best way of checking if a value is a number. So a real number, not a string. All right. So let's try again this one here, trying to convert it. And we know that this here is not a number. So literally, this will be NaN, right? And so this should be false as well. And it is. And now finally, this last use case, which gives us infinity. And so it is false as well. So that's where the name of the method actually comes from. So it's finite. And so infinity is, of course, not finite. All right. And so this method is the ultimate method that you should use to check if any value is a number, at least when you're working with floating point numbers. So if you are sure that you just need to check for an integer, then you can use isInteger as well. So let me just write here a comment as well. So this one you should only use to check if value is not a number. So literally not a number, this value. Okay. But usually in practice, I never use this. Whenever I need to check for a number, this is the one to go. Or if I'm using integers, then I use isInteger, as I was just saying before. So we can do this. Also, this is also integer, remember. And so both are true. Okay. But then, of course, if we try this here, it will be false. Now, in our project that we're currently building, there is not really a need to check if any of the inputs is really a number or not. And so in this particular case, we don't need to go back and change anything. But it's still good to know about especially this method here. So this is your go-to whenever you need to check if something is a number or not. And going back here, the parse float function should be your go-to whenever you need to read a value out of a string, for example, coming from CSS. So then you always get this, and it's very nice to be able to read the number out of this string. Let's now learn about some more mathematical operations and also about rounding numbers. And we have already been using lots of mathematical operations. For example, plus, minus, times, divided, exponentiation, and so on. And so we don't need to go over these again. So let's start here with the square root. And so just like many other functions, the square root is part of the math namespace. So math.sqrt. So this stands for square root. And so all we need to do is to pass in the number, and then it will give us the square root. And the same could be achieved using the exponentiation operator as well, by doing 1 divided by 2. And so that 2 is the square. So we want the square root, so we use 1 divided by 2. And actually we have to put this into parentheses, and now it works. All right, and the same would work for a cubic root, for example, of 8, which would be 2. And so actually this is, I think, the only way you could calculate a cubic root if you need it. Next up, let's get the maximum value of a couple of values, okay? So again, we use math and .max this time. So let's just use a couple of numbers here. And so, as the name says, the maximum value gets returned to us. And this max function here actually does type coercion. So it should now still give us 23, okay? However, it does not parsing. So if we try 23 pixels, for example, it will then result in not a number. So this does not work. All right. And just as we have max, we also have min. Let's just put it back to 23. And now here we get 2. All right. Now, besides a couple of methods, there are also constants on the math object or on the math namespace. And so, for example, if we wanted to calculate the radius of a circle with 10 pixels, we could do that. So for that, we use math.pi. And for now, let's just take a look at that. And so it is this constant that you might know, probably. And so again, let's say that we get like 10 pixels from the user interface. So we can say parse float of 10 pixels. And then we simply have to square this value. This is how we calculate the area of a circle with this radius. All right. Now, another thing that is on the math object is the random function that we already have been using a couple of times. And it's very important to be able to generate good random numbers when we need them. So before, we have already created random dice rolls, remember? So that we did by math.random. And so this will give us a number between 0 and 1. So as I reload, you see I get different values. Then we multiplied this by 6. And then we removed basically the decimal part by doing math.trunc like this. Okay. Now the problem with this was that then the highest number could be 5. And so we simply added +1 to offset that truncation here. So that cutting off of the decimal part. And so now we're going to get values here between really 1 and 6. But now let's actually generalize this formula so that we can use it from now on to always generate random integers between two values. So let's create random int. And we want to pass in a minimum and a maximum. And then we want to return that number. So as always, we need to start by removing any decimal parts of the result of math.random. And then we will multiply this math.random by max minus min. Okay. And then we add that 1 back on. And so let me show you why we do this. So it is because it gives us a number between 0 and 1. So math.random is between 0 and 1, right? So if we multiply this by max minus min, then we get a number between 0 and max minus min. Okay? And now if we add min to all of this, so the minimum value, then we get min to max minus min plus min. So we added min on both sides here, basically of the equation. And so then we can cancel this minus min plus min, and we end up with a range between the minimum and the maximum value that we specified. All right. So let's just add that here as well. So adding that minimum that I just explained here in this last step. And so this is how we end up with a nice function which will give us always a number that's going to stay between min and max. So let's try that out. So random int, let's say between 10 and 20. And so here we see 20, and let's try it a couple of times. So I'm going to save this file here a couple of times. And you see that all of these results are always within this range. Now I maybe overdid it. Probably it's easier to just reload this page. All right, so we haven't seen any 10 or any 11 yet, but it's going to work just fine. And we will get it if we reload it even more times. Okay, next up, let's talk a little bit about rounding. And let's start by rounding integers. So you can add some comments to this here if you want. but I'm just going to leave it like this. I will just add here rounding integers. And so we have already been using math.trunk, right? So what this does is to simply remove any decimal part. And so we end up with 23 here, right? Let's just take this one out. All right. So again, this one simply removes any decimal part always. But we have also other ways. So we also have round. So math.round. And so this one will always round to the nearest integer. So this one is going to be 23 and the other one 24. Let's duplicate this a couple of times to save us some time. Then we also have ceil. And this one will basically round down. So both of these results should become 24. And so that's these two here. So line 318 and 20. Or actually, it's these two. So I'm confusing these numbers. All right. So both of these are 24 because they will both always be rounded up. And then we also have a floor. And so these two will both be rounded down to 23. And so that's what we get here. And by the way, all of these methods, they also do type coercion. So if we do this, then it's going to work just the same. Now you might think that floor and trunk are very similar. We just put this one down here. And indeed, they do the same when we are dealing with positive numbers. So basically, floor and trunk both cut off the decimal part when we are dealing with positive numbers. However, for negative numbers, it doesn't work this way. So let me compare them here. So trunk minus this and also floor. Okay, and so now this one here, just like before, gets truncated. So it simply removes this part. But floor now gets rounded to minus 24, because with negative numbers, rounding works the other way around. And so actually, floor is a little bit better than trunk, because it works in all situations, no matter if we're dealing with positive or negative numbers. And so here, let's go ahead and replace this with floor. So we're looking for a really generalized function here. So this random int function should work in all situations, even if we give it negative inputs here. And so therefore, we need to work with floor here. All right. So that's rounding integers. Let's talk about floating point numbers. Or we can also say decimals. And now with decimals, it works in a little bit different way. So let me show you how. So in decimals, we have to specify the number like this in parentheses. And then on that number, we call the toFixed method. Okay, and let's try it here with 0 first, just so we can see the result. And so you see that with 0, it is converted to 3. But this 3 is white here, while these other ones are pink or purple. And so this means that is actually a string, right? So toFixed will always return a string and not a number. And that's important to keep in mind. So if we set here instead of 0, the 3, then it returns 2.7 and it adds zeros until it has exactly 3 decimal parts, just like we specified here. All right. Now let's add something more here, like 2, 3, 4, 5. And let's say we only want 2 decimal places here now. So this should become 2.35. And indeed it does. Okay. And if we now wanted to convert this result to a number, then we simply would have to add the plus sign here. And then we already know that this here converts a string to a number. And indeed, now it is purple again. So with decimals, it works differently than with integers. And that's once again because things in JavaScript evolved kind of in a weird way in this kind of old language. And if the language was designed today, definitely this would be very different. But yeah, this is what we have to work with right now. Okay? Just keep in mind that this here works in a similar way than the string methods. So this is a number, so it's a primitive, right? And primitives actually don't have methods. And so behind the scenes, JavaScript will do boxing. And boxing is to basically transform this to a number object, then call the method on that object, and then once the operation is finished, it will convert it back to a primitive. Okay? All right. So once again, this lecture looked a little bit like a reference of a couple of different methods. But to make it a bit more fun, let's now apply some of this to our Bankist project. And the first thing that I want to do is to round the requested loan amount. So this one here. So this looks weird. Oh, it's because of this number. Okay. So we could use this application in this other page here on the other side, but I prefer to have everything here in one screen. But anyway, I can take a loan like this, right, with the decimal part. But in practice, I've never seen a bank giving out a loan like this. And so let's apply the rounding to the loan functionality. So that's here. And the rounding then needs to happen right here. So the value that we get from the loan here needs to be rounded down. Okay? And then we actually do not need to convert it to a number, because as I showed you before, the math.floor method actually does type coercion itself. Okay? And we are using floor here because we simply want to round any value down. All right? So in this case, it would have been 150, and that's it. So let's try that again now. So let's ask for 150.56. And so now we get just this. Okay, probably I added one more zero there, but that doesn't matter. Next up, let's use the toFixed function or method to make our numbers here look a little bit nicer. So here, for example, we have this decimal part with the two numbers, but here then we only have the 0.9. And so this should be like 0.90. And here it should be 1300.00. And the same also up here. All right. So for that, we can use the toFixed function that we just learned about. And so let's do that in all the places where we display numbers on the screen. And so that's in these three functions. So display movements, display balance, and display summary. So let's start here at the top. And so here we have the first occurrence. So this movement here is a value, so it's a number that we display. And so on here, we can simply call, so .to fixed, and then with two decimal parts. All right. And now let's just copy this from here. So display balance. So let's do the same here. And the same in the summary. And so that will then hopefully also fix this weird, really long number that happens because of the rounding errors in JavaScript that I just explained you in the previous lecture. So everywhere we print a number, I will do this now. So, okay. Then also on this result, and also on the interest. Let's give it a save. And that's a lot better. So it worked. You see, now we get 0.00. And here we also get nicely 0.90. And the same down here. We are now back to having just 2 decimal places, just as we requested, so to say. So this lecture was kind of a short overview of some more math functions, including some rounding and also some other stuff like getting the max and the min value. And yeah, so good to know functions. And of course, there are a lot more. So if you need something like logarithmical functions or sinuses, then of course you can always check out the MDN documentation. One operator that I didn't mention in the last lecture is the reminder operator. And the reason for that is that the reminder operator has actually some special use cases, and so it deserves a lecture on its own. So what is the remainder operator? Well, as the name says, the reminder operator simply returns the remainder of a division. So let's check that out. So the remainder operator is this one. So the percentage sign. And so let's check what 5 remainder 2 is. And it is 1. So why is that? Let's say we divide 5 by 2. And so then we get 2.5. But if we took only the integer part, so only 2, then the result would be 2. Okay? So if we did the division only until the integer part, then that result would be 2, because 2 times 2 is 4, but then there would be the remainder of 1, right? Because 5 minus 4 is 1. So we can say that 5 is 2 times 2 plus 1. All right, and so this here is the remainder, and therefore 5 remainder 2 is 1. Well, let's try another one. Let's say 8 remainder 2, or 3 actually. And so now the remainder is 2. Okay, and if we did 8 divided by 3, then we would get this number here. But again, if we only took the integer part, so 2, then we would only end up with 6. So 2 times 3 is 6. So let's write that. 8 is 2 times 3. So this 3 here times 2 plus the remainder, which is 2. So 6 plus 2 is 8. And so 2 is that remainder. And therefore, that's the result that we get here from the remainder operation. All right. So maybe you're not yet familiar with this concept, and so I hope that it made sense. Now, one thing that is many times useful in programming is to check whether a certain number is even or odd. So even numbers are 0, 2, 4, 6, 8, 10, and so on and so forth. And the odd numbers are all the others. So 1, 3, 5, 7, etc. So when is a number even? Well, it's even if it is divisible by 2. And divisible by 2 means that if we divide it by 2, the remainder is 0. So let's check that. So 6 is an even number, right? And so the remainder of dividing it by 2 is 0. And that's because dividing 6 by 2 is an integer number. So it's exactly 3. So 3 times 2, so this 2 here gives then 6. All right. But on the other hand, an even number is, for example, 7. All right. And so here we have the remainder as 1. And that's because 3 times 2 is 6. And then plus 1, which is the remainder, is 7 again. And so just like 5, which is also an odd number. Okay? And so now we can use that knowledge to check whether a certain number is even or not. So let's create a function is even, and a simple arrow function is perfect here. So if the remainder of n with 2 is equal 0, well then of course this will return true. And otherwise it's going to return false. So when it's 1, then the result of this function will be false. So let's use this. Is even, let's try with 8, 23, and maybe, well, something else. Doesn't really matter. And so intuitively, we know that 8 is an even number, and so we get true. This one is an odd number and an even number, and therefore we get the correct results. Okay? And so, of course, this works to check if any number is divisible by any other number. All right? And whenever the result of the remainder operator is 0, then that means that the first number is completely divisible by the second one. And again, this is sometimes very important to know in programming. So let's see another example here involving our application. Not really in practical terms, but just to have some fun. So let's select all of the rows of our movements. So yeah, let's check the HTML here. So each of the movements is this row, so this element with this class. And so let's select all of them, and then we will paint them a little bit based on some conditions. So let's select all of these elements. So all. So that's dot, and then this class name. And so this here will return a node list. And so let's convert it to a real array. And for that, this time I'm going to use the spread operator. So I will spread all of these elements into this newly created array. And then on that array, I can immediately call for each. And so let's specify a callback function with the current element, which is the current row and the current index. All right. And now let's say that I wanted to color every second row of the movements. So all I have to do is to check if the current index is divisible by 2. So I, which will start at 0, then it's going to be 1, 2, 3, 4, and so on and so forth. So if I want to color every second row, then if I do this, then every second number will be divisible by 2, and every other second number will not. So I can just check if it's 0, and if it is, then I take the current row, take the style, and change the background color. And remember that we have to use camel case notation here. And let's change it to orange red. So just to make it a little bit fun. Okay. And actually, just like before, this here actually has to happen inside of a handler. So an event handler function, because this code here will execute right when we start our application. But then as we log in, we overwrite that with the deposits of the current user. And so let's again do that as we click here on this balance, just so that we have like any reference point. Okay. And now let's try this again. All right. And now as I click this label, well, like magic, every second row is now painted in orange red. So beautiful, right? Well, not really, but at least we know that our code worked. All right, let's do another one. So now let's say that I want to paint every third row also in even another color. And so I do the reminder of 3. And each time it is equal to 0, then I do set this background color to blue. All right. And so this here will be at 0, 3, 6, 9, and so on and so forth. While this one here is going to be, as we already saw, at 0, 2, 4, 6, and so on. And you see that there's going to be some overlap here, but that's not a problem. Here we are missing the R. Give it a save, and just try it one more time. So this is just for fun, of course, but there could be real applications to this. So you see that now every third row is indeed blue. So really nice looking effect that we just created here. But yeah, it's just to illustrate really how the reminder works. So whenever you need to do something every nth time, so to say, so every nth time, then it is a good idea to use the reminder operator for that. So here, for example, every second time, every third time, but of course this might then depend on your specific need, maybe in your application. So this is how we use the reminder operator, yet another one in your toolbox now. And with that, let's go straight to the next video. Starting from ES 2021, we can use a feature called numeric separators to format numbers in a way that is easier for us or for other developers to read and to understand. So let's say that we wanted to represent a really large number. For example, the diameter of our solar system. So let's say diameter, which is 287 billion and 460 million. And just from looking at this number here, it's really difficult to read and to understand it. So does this mean like 28 billion, or is it just 2 billion? Or really, what is this number? It's really hard to read like this. There's just too many zeros here, right? Now, to help with this, when we write a number this large in the normal English language, we usually use a thousand separator like the comma. So we would write this number like this, right? And then it becomes really easy to immediately see that this means 287 billion and 460 million. And now, fortunately, we can do the same thing in JavaScript as well, using the new numeric separators. So numeric separators are simply underscores that we can place anywhere that we want in our numbers, and which will make it then really easy to understand and to parse numbers this large. So using the underscore here as a thousand separator then makes it really easy to understand that this number here means in fact 287 billion. Now let's just log it to the console to see what JavaScript actually sees. And so here we see that in fact the engine basically ignores these underscores, so these numeric separators. It simply sees the number itself. And so what this means is that we can actually place the underscores, so the numeric separators, anywhere that we want. So let's do another example. Let's call this one price in cents, and I'm going to set it to 345_99. And so again, using the underscore here then makes it really obvious that this is actually a price in cents. So of course the number itself does again not contain the underscore, and so our price is indeed 35,599 cents. But by placing the underscore here, it makes it really obvious that we have first this value here and then this other value here in cents. And in fact, it's so obvious that we could even get rid of the cents part here in the variable name, right? So basically, we can use the underscore now to give meanings to certain parts of our numbers. So here we said that these are thousands, and here we said that these are cents. So let's try another one. Let's call this transfer fee. And here again, we place the underscore like this. And so here immediately it looks like it is $15, for example, and 0 cents. But if we did the same thing like this, so placing the underscore here, then it suddenly looks like 1,500, right? While in fact, it is the exact same number. So both of them are exactly 1500s, but just the underscore alone gives them different meanings. And so we can use that to our advantage whenever we write numbers in our JavaScript code. Now, another variable here called pi, and this one is to show you some restrictions as to where we can place the underscore. So pi is 3.1415, and we can only place underscores between numbers. So we could place it here, and there would be no problem at all. Let's just log it. But actually the underscore doesn't make a lot of sense here. So let's remove it, and let's say we wanted to place it here. Well, here we get then an error because that is not allowed. It's also not allowed to place here, and also not at the beginning of a number or at the end. So all of these are illegal, and yeah, like this it works, but we can also not place 2 in a row. So the error message here is pretty explicit about that. Okay, and now just one final detail that we need to be aware of is that when we try to convert strings that contain underscores to a number, that will not work as expected. So let's try to use the number function that we learned before to convert a number. So of course with this, it should work just fine, right? So we have 230,000, the number, or actually the string, and then here it converts to a number. However, if we place an underscore here, so if we wanted to have a numeric separator here, that would not work. So now it is not a number. So what that means is that you should really only use these numeric separators when you are writing down numbers like this. So really in the code. If you need to store a number in a string, for example in an API, or if you get a number as a string from an API, you should not use underscores in there, because then JavaScript will not be able to parse the number correctly out of that string. So it's not going to work as expected, and you will get this not a number that might then introduce bugs into your application. And the same is true with the parse int function. So here we do not get not a number, but we only get the 230. So only the part that is here in front of the underscore. Everything else will then be ignored. Let's now meet one of the primitive data types that we never talked about before, and that is big int. So big int is a special type of integers that was introduced in ES 2020. And so let's quickly take a look at it. So we learned in the first lecture of the section that numbers are represented internally as 64 bits. And that means that there are exactly 64 ones or zeros to represent any given number. Now, of these 64 bits, only 53 are used to actually store the digits themselves. The rest are for storing the position of the decimal point and the sign. Now, if there are only 53 bits to store the number, that means that there is a limit of how big numbers can be. And we can calculate that number. So that's 2 elevated to 53, and then minus 1 because the numbers start at 0. And so that is this gigantic number right here. And so this is essentially the biggest number that JavaScript can safely represent. Okay? Or actually it's 53. So this is the biggest number, all right? And it is 2 because, again, we are working with base 2, which is only zeros and ones. And this number is so important that it's even stored into the number namespace as max save integer. So this gives us the exact same number, all right? So any integer that is larger than this is not safe. And that means it cannot be represented accurately. So let's duplicate this line here. And for example, add 1 to this. And so you see that this is not correct, right? It only added one number to this one where it should have been added to. So if we do this, then we get the exact same thing. So we keep adding numbers here, and they are always the same. And so that means that JavaScript can simply not represent these numbers accurately. And so if we do calculations with numbers that are bigger than these, then we might lose precision. Okay? So in some numbers, it does actually work for some reason, but that's because JavaScript behind the scenes uses some tricks to still represent some of the unsafe numbers. But again, sometimes that works, sometimes it doesn't. And so that's why we call these unsafe numbers. So you see, sometimes these numbers are, or at least look correct, and sometimes they don't. Okay? So this can be a problem sometimes, because in some situations we might need really, really big numbers, way bigger than this one here. For example, for database IDs, or when interacting with real 60-bit numbers. And these numbers are actually used in other languages. And so we might, for example, from some API, get a number that is larger than this, and then we have no way of storing that in JavaScript. At least not until now. Because now, starting from ES 2020, a new primitive was added, which is called big int. All right? And big int stands for big integer, and it can be used to store numbers as large as we want. So no matter how big. All right, so let's say we need this number, and I'm just using random numbers here. So if I log this, then you see, well, this here, which probably does not have precision because, of course, it's larger than this. But if I use the n, then this will be a big int. So let's see that. And so this n here basically transforms a regular number into a big int number. And you see in the console here, it then also does look different. Okay? So this is a really, really huge number. But now JavaScript has a way of finally displaying this number here accurately. All right? We can also create big ints by using the bigint function. So sometimes that's necessary, and then without the n. And so this gives us kind of the same result. Well, not really for some reason, but I guess it is because JavaScript will first have to still represent this number here internally before it can then transform it into a big int. And that's the reason why here from a certain point on, this second number is different. So this constructor function should probably only be used with small numbers. For example, like this. Okay, so this is how we create big int numbers. But let's now see some operations with these numbers. And, well, basically it's very simple. All the usual operators still work the same. So let's say we have 1 or 10,000 n plus 10,000 again. And so in this case, of course, we wouldn't even need a big int here, but this is just to demonstrate that the operators work just the same with big int. So we get indeed 20,000. And the same is true with other operations. So for example, a multiplication, let's try a really huge number, 10 times this other huge number. And so it then gives us this result. Now, what is not possible is to mix big ints with regular numbers. So let's say we have huge, so some random number like this, and then we have a regular number, which is just 23. And so if I wanted to multiply them, so huge times num, then we would get this error. Cannot mix big int and other types. All right. And so this is where we then would have to convert this number here to a big int. And this is where the constructor function that I showed you here becomes necessary. And so now it is indeed going to work. However, there are two exceptions to this, which are the comparison operators and the plus operator when working with strings. So let's see that. So we can still do a big int and then, for example, greater than a normal number. So this still works and we still get true as expected. Okay. However, when we do this, so 20n equal 20, we will get false. But that makes sense because JavaScript, when we use the triple operator, does not do type coercion. And in fact, these two values here, they have a different primitive type. This is a regular number and this is a big int. In fact, we can check that, or at least I think we can. I never did this actually. But yeah, indeed, the type of this is a big int. All right. But however, if we do the regular equality operator, so the loose one, then this should still be true, right? Because then JavaScript does the type coercion, and so then it will coerce this one to a regular number, and then they are both the same. So just like, so it would even work like this. So this is one exception. Let's write that here. So logical operators are one exception, and the other exception is when we do string concatenations. So let's say huge plus, and then some string here is really big. And so you see, in this case, the number is then actually converted to a string. So even the big int number. Okay. Now, one other thing that I didn't tell you up here is that also the math operations that we talked about earlier are not going to work here. For example, we cannot take the square root like this, QRT of 16n. All right, so that doesn't work. All right. Finally, let's take a look at what happens with divisions, because big int is indeed an integer. So what happens if we do this? 10 divided by 3n. And we know that with normal numbers, this would not be an integer, right? So 10 divided by 3 is 3.33 until infinity. So here. But with big ints, it will simply then return the closest big int, right? Let's try it with 11 here. And so it simply basically cuts the decimal part off. Of course, with 12, it would then be 4, right? But with anything else, it will then cut off the decimal part. Okay, and basically, this is all that I have to tell you in an introduction video like this one about big int. So this new primitive type adds some new capabilities to the JavaScript language when you really need to work with like huge numbers, just like this one here, for example. Now in practice, you will probably not use this very much, but it's still good to know that big int exists and also how it works. When we build real-world applications, one type of data that comes up all the time is dates and times. So let's learn the fundamentals of dates and times in this video, so that in the next one we can then implement them into our application. Now, dates and time can be a little bit messy and confusing in JavaScript. And so just like with numbers, I will try to make the fundamentals here as clear as possible. So first, we need to actually create a date. So create a date. And there are exactly 4 ways of creating dates in JavaScript. I mean, they all use the new date constructor function, but they can accept different parameters. So let's see how. So the first way is simply to use the new date constructor like this. And then we can assign this to a variable. And let's just call it now. And then here I'm logging now to the console. And so we get the current date and time at this very moment. So you see that Sunday, August the 2nd, 2020, and plus this time here. Next up, the second way is to parse the date from a date string. So again, we use new date, and then we can pass in a string. And for example, this string here would work just fine. For example, just this part here. Okay, so simply giving JavaScript a string here, and it will then automatically parse the time based on that. And so that's the second date that we get here. But we can also, of course, write a string ourselves. For example, let's try Christmas here. So we can even write December 24, 2015 or something. And so indeed, that works. And we even get the day of the week here. So JavaScript is pretty smart in parsing out this string that we write here. Now, however, it's generally not a good idea to do this because it can be quite unreliable. All right. However, if the string was actually created by JavaScript itself, then of course it is pretty safe. So actually in our accounts object, or in our account 1, for example, we now have these dates. So movement dates. And so let's try to parse this string here. So let's create a new date object in JavaScript based on that string. So that's in account 1 dot movement dates and then 0. All right. So again, this is okay because it was JavaScript who created that date that I just showed you there. So this date here. And by the way, this Z here means the UTC. So that's the coordinated universal time, which is basically the time without any time zone in London and also without daylight savings. So that's based on a string, but we can also pass in year, month, day, hour, minute, hence even second into this constructor. So let's say 2037 and 10, 19, 15, 23 minutes and 5 seconds. So indeed, we get November 19, 2037 at 15 hours, 23 minutes, 5 seconds, just as we have here. Now you might have noticed that here we have 10, but November is actually the month 11, right? And so that means that the month here in JavaScript is 0 based. And that's a little bit weird, but well, we can just get used to that, right? Now, what's cool about this is that JavaScript actually autocorrects the day. So let's try this here again differently. So let's try November 31st. But we know that November only has 30 days, right? And so if we take a look at this, it will then autocorrect right to the next day. So that's going to be December 1st. And we can even try November 33rd, which should then be December 3rd. Okay, so this sometimes is actually pretty useful. Finally, we can also pass into the date constructor function the amount of milliseconds passed since the beginning of the Unix time, which is January 1st, 1970. So let's see that. So again, new date. And if we pass in 0, so 0 milliseconds after that initial Unix time, then indeed we get January 1st, 1970. Okay, and this will actually be pretty useful, even though it looks a bit strange. And let's now create a date that is 3 days after this. And so that is essentially 3 times, which is 3 days, and 1 day is made out of 24 hours, which is made out of 60 minutes, which is made out of 60 minutes, which is made out of 1000 milliseconds. And so this is how we convert from days to milliseconds. So 3 days times 24 hours, which is the number of hours in 1 day, times 60, which is the number of minutes in 1 hour, then times 60, which is the number of seconds in 1 minute, and then times 1000 to convert to milliseconds. And so now we get January 4th. So that's exactly 3 days later. Okay, and this number that we calculated here, that's actually calculated also here. So this is the timestamp. So we call this here a timestamp of the day number 3, essentially. And we will see why this is useful a little bit later. Now, these dates that we just created here are in fact just another special type of object. And so therefore, they have their own methods, just like arrays or maps or strings. And so we can use these methods to get or to set components of a date. All right. So working with dates here, and let's now actually create a date again. And this time we're going to store it in a variable. Let's call it future. So new date, and let's actually use the same as this one. Okay, just without the seconds, that's not really necessary. Okay, let's just log it to the console here to make sure. Okay, and let's, for now at least, just comment out these here. So we already know how it works. Now we just want to work a little bit with this particular date. So we can use future, which remember is simply this object here, and then the method get full year. And so indeed we get 2037. There's also get year, but never use that. Okay, always use get full year. Don't make the mistake of using that other one. Next up we have get month, and remember that this one is 0 based. So 10 is actually the month number 11. Then we have get date, and this is actually the day. So I think that this method has a little bit of a weird name. And so that's because get day is actually not the day of the month, but the day of the week. Okay, and 0 here is Sunday, and so 4 is the Thursday. So we saw already that it's Thursday, and so that's equivalent to number 4. And then besides these, we also have 3 more, which is get hour or hours, minutes, and seconds. So sometimes these can be pretty useful to work with a date. Besides that, we can also get a nicely formatted string. So basically similar to what we have up here, to ISO string. All right, so this is the ISO string, which follows some kind of international standard. And maybe you noticed that this is actually similar to the string that we used before coming from account 1. So that's movement dates, right? So these were generated by exactly this method. And so that's one of the very useful cases, is when you want to convert a particular date object into a string that you can then store somewhere. Finally, we can also get the timestamp for the date. And remember that the timestamp is the milliseconds which have passed since January 1st, 1970. So get time. And so we see that this huge amount has passed, well, since that date. And now we can take this number and reverse this. So if we wanted, we could now create a new date only based on these milliseconds, and it would then give us exactly that same time. So you see, it's the same as this one, right? And so simply based on the milliseconds that have passed since January 1st, 1970. And timestamps are actually so important that there is a special method that we can use to get the timestamp for right now. So if you want simply the current timestamp for this exact moment, then you don't even need to create a new date. All we have to do is to call date.now. And that then gives us this timestamp. Okay. Finally, there are also the set versions of all of these methods. So let me just show you the one for the year. So I'm not going to go through all of them here. And so future.set full year. And this again is a method. So let's set it to 2040. And then we can take a look at our date. And so now it is November 19th, 2040. And of course, then the day of the month here has changed. And so yeah, there also exists set month, set date, set day, and so on and so forth. And these also perform autocorrection, just like here when we create a new date. Okay? So that's basically all the methods that you need to know about dates. And these last here are all quite intuitive, and all you need to know really is that there are all these different ways of creating dates. Now in the next video, we will then sum up what we just learned here to add dates to the Bankist application and make our project even better.